All right, we want to find the derivative of the following function. So we have y equals x squared sine to the fifth of x plus x cosine to the negative second of x. I'm going to rewrite this just due to the weird notation that we have around sines and cosines so that we can see the chain rule that's coming out here. And so we have the sine of x to the fifth power, and we have the cosine of x to the negative 2 power. So when we go to take dy dx, we'll have to take a derivative across all of this function. And so as we take the derivative, the first thing we're going to run into here is a product rule. So I'm going to take the derivative of the first times the second, and I'll rewrite it in this form, plus the first times the derivative of the second. Well, the derivative of the second has a chain rule, so I'll bring the 5 back out. We'll take the 5 down out front, times sine of x to 1 less power times the derivative of what's in here, which is cosine x. So in taking our rules, we did product rule 2 of x times sine to the fifth of x plus the first times the derivative of the second. And so this fifth power here, I pull the 5 back in front and I bring the power down to 4. But because it's chained, I have to take the derivative of what's inside of here. So I get this 5x squared sine to the fourth of x cosine of x. Now I'm going to come over here and we have a product rule again. I'm going to get cosine negative 2x because the derivative of the first is 1 times the second, and plus the first times the derivative of the second. So I'm going to bring the negative 2 out front, and I'm going to bring the power down by 1. But I still have to do the derivative of what's inside of here, and so that's negative sine of x using the chain rule. And so we'll tidy this up. I get 2x sine to the fifth of x plus 5x squared sine to the fourth of x cosine x plus cosine to the negative 2 of x. A negative times negative is positive, so 2x cosine negative 3x sine of x. And that is our lovely derivative using our chain rules.